Welcome to Subject of Formula. In this lesson, I'll be walking you through how to solve problems related to subject of formula. What do we mean by subject of formula? It simply means the art of changing the subject of a particular equation to another one. For an instance, you're given the equation v equals to u plus at. So in this equation, v is the subject of formula here. So the question might look like this that you might be given. You might say, make u the subject of formula. So if you're making u the subject of formula, so you have the answer to be u equals to v minus at. You get the idea? Okay, so u is now the subject of the formula there. Then in another example, you might be given to make a the subject of the formula. And when you're making a the subject of the formula, that means you have a equals to v minus u over t. So in this particular example here, a is the subject of the formula. So just sit back, I will show you different examples of how you can solve your subject of formulas. Things you need to note in subject of formula. The very first thing you need to note is operator sign must change when going from one side to another. When the minus sign is moving, you know this minus now is at the left hand side. If it goes to the right hand side, you can see is equal to is separating them. The sign will change to plus. So if the plus sign, if we have plus sign at the left hand side and it goes to the right hand side, the sign will change to minus sign. Okay, for instance, you are given an equation v equals to u plus at. In this particular equation, if you ask to move u from the right hand side to the left hand side, you can see that u is not having any negative here. It means u has a hidden plus. So this u is plus u. So if you transfer plus u to the left hand side, it will become minus. And so you might have something like this: v minus u equals 80. You know, plus 80 is the same thing as you saying 80. You can hide the plus. Let's also look at another things we need to consider when we are solving a subject of formula. When you need to remove square from any side, either left hand side or the right hand side, all you need to do is to square root both sides. Okay, what do I mean by this? For an instance, you are given an equation v square minus 2as equals to u square, and you are asked to make u the subject of the formula. You can see the u right here, and the square is on top of the u. So all you need to do to remove this square on top of the u is to just say square root both sides. Square root both sides, and then you have something like this. That means the left hand side will be square root and the right hand also will be square root. By so doing, the square root will cancel out the square, and then you now have only u left here. Okay, let's also look at another thing we need to consider. So when you need to remove square root from any side, either from the left hand side or from the right hand side, all you need to do is to square both sides. For an instance, you're given an equation p equals to square root of 2qh over 100. If you look at, you are trying to make maybe h or q the subject of the formula. If you're asked to make, for an instance, h the subject of the formula, you can see that we have this barrier that will prevent us from getting to our h. So all you need to do there, since this is the square root, you need to say square both sides. So when you square both sides, that square will be able to cancel out this square root. So we have something like this. When you square both sides, we have p square, that's the left hand side, equals to, then the right hand side, everything you have here, you raise to power 2, as you can see here. In that scenario now, then the square will cancel out the square root, and so what you might have left at the right hand side will be 2qh over 100. Getting ready to show you the example 1. So in our example 1, we are asked to make A the subject of the formula V equals to U plus AT. The very first thing you need to do, try and write down the formula first, which is the V equals to U plus AT. You know that our V is at the left hand side and our U plus AT is at the right hand side. Okay, so what you are asked to make the subject of the formula, where is it? Okay, this is the A here. We're asked to make A the subject of the formula, so is within this A and T. So any other thing that we are not making the subject of the formula, we transfer it to the other side. So we are transferring this U to the left hand side to meet the V. You can see that this U doesn't have negative, doesn't have minus here. It means it has a hidden plus. So this is plus U. When you transfer plus U to the other side, which is the left hand side, the sign will change to minus, and then we should have something like V minus U. You can see that. Then equals to, then at our right hand side, what is left should be plus 80. So plus 80 is the same thing as you saying 80. We can hide the plus, and you can see right there. Then the next thing to do now is, you know, we are to make A the subject of the formula. Then this T is preventing us from getting our A. So what you need to do there, to cancel out this T, you just say divide both sides by T. So when you divide both sides, that means you're dividing the left hand side by T and the right hand side also by T, and we have something like this: V minus U divided by T equals to AT divided by T. As you've done that, so the T here will cancel the T here, and then what we have left at the right hand side is just A all over 1, and that is just A. Okay, the next thing will now be, we have V minus U over T equals to A. So we can interchange it round, maybe by bringing A to the left hand side and taking V minus U over T to the right hand side, and we have A equals to V minus U over T. That is the final answer. Let's look at example 2. In this example 2, we are asked to make U the subject of the formula. In between, we have V squared equals to U squared plus 2AS. Write down your formula that you're given. Remember, we are asked to make U the subject of the formula. So this is where our U is. Our U is located here. So all we need to do, any other thing that we are not making the subject of the formula, we have to transfer it to the other side. You know that this V square is at the left hand side, and then this U square plus 2AS is at the right hand side. So we need to transfer this plus 2AS to the left hand side, so that we can have U square remaining at our right hand side. So transfer plus 2AS to the left hand side. Your plus here, when you go to the left hand side, the sign will change to minus, and then we should have V square minus 2AS. You can see that then we have equals to, what is left at the right hand side would only be U square. Okay, so the next thing to do now is, you know, we are making U the subject of the formula. And you can see that we have something that could also prevent us from getting to our U. So all we need to do now, this is a square. So how do we remove that square? If you remember the notes I talked about, to remove your square, all you need to do is to square root both sides. So you will square root your left hand side, and you also square root the right hand side, and then we have something like this. square root of v square minus 2as equals to the square root of u square. And then in this scenario now, the square root will cancel out the square, and then we have u left there. Okay, now we have square root of v square minus 2as equals to u, because u is left here. And then we can interchange it around. Since we have only u here, so we can interchange it around and say we have u equals to square root of v square minus 2as. That is our final answer. So this is our subject of formula here is u equals to square root of v square minus 2as. Let's also look at example 3. In this example 3, we have to make m the subject of the formula if d equals to 1 over 3 mk square. Okay, write out the formula you're given first, and then we have d equals to 1 over 3 mk square. Don't be confused here. The very first thing you need to do, maybe you can just try to expatiate this out. 1 over 3 multiplied by mk square. So in this you can say over 1, since this one is a fraction, 1 over 3 is a fraction, so mk square over 1 is the same thing as mk square. So when we say multiply the numerator side is 1 and this mk square, so 1 times mk square will still be the same thing as mk square. Anything multiplied by 1 will still be the same thing. Over 3 multiplied by 1 will give 3. So you can see right there we have mk square over 3 for this 1 over 3 mk square. Okay. We have d over 1. You remember that d over 1 is the same thing as d. Okay, the reason why we're doing this d over 1 right here, because this fraction here we have equals to mk square all over 3. If you remember, we have this right now. The next thing to do is to do what is called cross multiplication. So cross multiply, indicate that with your arrow. Okay, when you cross multiply, the first one will be 1 multiplied by mk square. So 1 multiplied by mk square, anything multiplied by 1 will give that same thing. So we have mk square there as at our left hand side, then equals to 3 multiplied by d, that will give us 3d. Okay, remember we are making m the subject of the formula. So since we are making m the subject of the formula, what can you see beside m that could hinder us from getting our m? Okay, you can see that we have k squared there. So this simply means m times k square. So in order for us to remove this k square, all we need to do is to divide both sides by k square. Okay, so when we divide both sides by k square, we're dividing the left hand side by k square and the right hand side also by k square, and we have something like this: mk square all over k square equals to 3d all over k square. Okay, in this now, that means at the left hand side k square will cancel out k square, and we have only m left at the left hand side. So we now have m equals to 3d over k square. So making m the subject of the formula, we have m equals to 3d over k square. Let's look at example 4. In this example 4, we are asked to change the subject of the formula to h if p equals to square root of 2qh over 100. Okay, write out your formula first, which is the p equals to square root of 2qh over 100. Okay, I want you to take a time and look at your formula first. Then ask yourself, what are you asked to make the subject of the formula? Well, you're asked to make h the subject of the formula. So how can you get to do that? Okay, before you could do that, you can look at this barrier right here, which is the square root. That square root is the first barrier that will prevent us from getting to our h. So all you need to do is to look for something to cancel out that square root. And to cancel out the square root, if you look at the note that we've looked at before, we said to cancel out a square root, you need to make use of your square. So you need to say, so this is your left hand side and this is your right hand side. Then all you need to do is to say square both sides. That means you're going to square your left hand side and you're also going to square your right hand side. So, and we now have something like this: p square equals to, then the whole of the right hand side square. You can see, so we have to bracket this and then put the square. That's the reason you can see the square right here. Okay, the next thing to do now, the square will cancel out the square root, and then what we now have left at the right hand side will only be 2qh over 100. Okay, so left hand side we have p square over 1. The reason why we said over 1 there is because of the fraction at the right hand side, which is the 2qh over 100. Okay, at this junction now, all we need to do now is to cross multiply. So apply your cross multiplication arrow. Okay, so we have 1 multiplied by 2qh. So anything multiplied by 1 will still give that same thing. So we have 2qh there, then equals to 100 times p square. That will give us 100 p square. Okay, getting here right now, remember, don't forget, we are making h the subject of the formula. So what are the other things that could disturb us from getting our h, from making our h the subject of the formula? Well, you can see those things will be 2q. So remember that this 2qh means 2 times q times h. Okay, so how do we now remove this 2q? To remove it is very simple. All you need to do is to say divide both sides by 2q. You understand? So when you divide both sides by 2q, 2q will cancel out at the left hand side, and then we have 2qh over 2q at the left hand side equals to 100 p square over 2q. You can see right there, that means 2 cancel out 2, and then q cancel out q, and then what we have left at our left hand side is h, and then at the right hand side is 100 p square over 2q. So we have h equals to 100 p square over 2q. The next thing to do now is to look at the numerator and the denominator side and see if anything can go through. Okay, if you observe very well, you can see that 2 can go in 100. Okay, 2 into, that is 1. Can 2 go in this one? No, 2 cannot go in 1. So all you need to do is to take the 1 and the next 0, and that will be 10. So how many 2 will go in 10? If you go to your 2 times table, you definitely know that that will be 5. 2 can go in 10 in 5 places. That's 2 times 5. So we have 2 times 5 to be 10. So we have 2 can go in 10 in 5 places. Then 2 in 0, that will give us 0. If you look at it there, at the numerator side we have 50p square, and then at the denominator side we have 1q. 1q is the same thing as saying q. So we now have our h equals to 50p square over q. So our subject of the formula is h equals to 50p square over q. That's our final answer.